Today we are going to be looking at an overview of ClearCalcs on steel column calculator in Australian standards. So let's add a new calculation. We are in the AU standards, steel column, generic column. Well, this shows us the details of the calculator. We are designing to AS4100 2020. And here are several assumptions listed here for the design. The first section to the left-hand side is our key properties to design our column. Firstly, we choose our sections. We can either select our section from the drop-down list or just simply type the section we want to be used. Then we design the height of our column. For example, we have a 10-meter column here. We design its restraint type, either descript or continuous. If we are not sure about any option, we can just simply click on the label and it will show the description and references. For the embrace and the effective length, ClearCalcs considers the lateral bracing, which restricts the movement of the X and the Y axis, while the torsional bracing restricts movement about the Z axis. By default, the embrace length is set equal to the column length, but it can be modified if additional bracing is used. For example, we can enter L/2 here if our column is braced at the middle of the Y-axis. The default of the length factor is assumed to be 1, which means we are assuming it is a pin-type restraint here. Alternatively, we can set a lower custom value if our column provides moment restraints specifically. We can design the support of our column, which is from the bottom to the top. For example, we just make our column to have a fixed base at the bottom, and we can also have a ruler at, for example, 7,000 millimeter to the bottom, and a pin support at the top. Then we decide whether our column is of a braced frame or a sway frame. If we choose a sway frame, we have to specify the sway amplification value. ClearCalcs doesn't provide a calculation here, but we can refer to the clause 4.4.2 in the code. Like all of our calculators, you can also include an unlimited number of loads in various locations. As we can see, we have a default load here, and we can definitely add more loads. For example, we can add a minus 10 kilonewton dead load here. Let's say a snow load of 12 kilonewton to the left, and a live moment load of 4 kilonewton meter here, and we name it like L2 and put it on 1/3 of the height to the top to the bottom. Alternatively, ClearCalcs also allow us to easily link the other design members from this project to our column. For example, we can link a previous design timber beam B1 here and put it at, for example, 1,000 millimeter to the bottom. The eccentricity, we can either type our own value here or select from the list. Similarly, we can design the lateral distributed loads and other loads. We can select whether we consider the self-weight of our column here or not. Then we can decide the character of imposed load for our column. For example, let's select residential and domestic here. So ClearCalcs also allow us to apply wind loads, lateral loads and moments at the Y-axis of our section. So we can input these loads accordingly by our design. The design criteria allow us to specify the limits for the deflection, and in member section, we can select our steel type, and the ClearCalcs also allow us to have penetration and holes in the web or in the flange. Scrolling down, we can find the load cases analysis, such as the compression capacities and all the alternative steps used to calculate our capacities. Finally, if we are scrolling up to the top, we can see our computed results are always updated in real time and located at the top right of the page under summary. We can also use the traffic light system to see if our design is passing or not. And below here, we have dynamic diagrams that shows reactions as well as the graphic loading combinations.